Hello everybody. Well, we've put a lot of miles onto our trenchers lately, and like anything else that runs in the dirt, eventually it's going to wear out. How soon that is depends mostly on what your ground conditions are, but also there's chain selection and general maintenance that you need to keep up on too. If you're curious about that drag box on the back of the trencher, check out my trenching sand video to get a more detailed view of it and how it operates. We like to run a rotary carbide bit. This style here has a C-clip on the back, which they're a little bit harder to change out, so we prefer to run the internal spring clip. Those you just tap out with a hammer and tap back in. That's one that's almost wore out. Pretty soon after that, the carbide will get knocked off the end of it. There's, of course, different variations of them. Some of them have the pocket protectors, some of them don't, all different lengths and sizes depending on what you're doing. So it's either that or cup teeth or shark's teeth for the most part. In places out here, the ground is hard enough and abrasive enough that cup teeth just don't seem to stand up very well. This set here has probably got between 4 and 5 miles of trenching on it is all, and they're completely toast. We've been running our own design on the holders for probably close to 20 years now. It sets up a little bit taller. It's about comparable to what the cup teeth cut for height, and it carries the dirt out a lot better than the lower profile rock teeth that you can buy through Vermeer or Ditch Witch or anybody like that. We're running a left and a right inside and a left and a right outside cutter. That one there is an outside cutter on the right side. We've got jigs made up to keep all the cutters consistent, just to hold them in place while you tack them. That one you just line up with the front. It keeps the angle right. The ones for the sides bolt into the holes on the side, and then you tack the tooth in place, and then you unbolt the jig and move on to the next one. So that one is an inside right cutter that we don't have the front pocket welded onto yet. We'll set the pocket onto the jig and then set it down onto there and tack it in place. It's a little bit of a project to get them all welded in place, but we like this chain set up good enough that this is a 4 set of complete cutters that we're on. So when you find something that works, stick with it. We're doing the welding work here with the Miller MIG welder with just CO2 on it. Part of the project we was using 35,000 wire, and then we finished up with 45,000 wire. It doesn't make a whole lot of difference. It welds about the same for the thickness iron that we've got here. This chain that we've got set up here has mostly got the original set of cutters that we built on it. Of course, we busted a few and lost a few over the years, but the majority of them probably have close to 150 to 200 miles of trenching on them. You can see where the pockets are getting some wear back in behind on the bottom side of the tooth here. This setup we're actually going to sell to another guy. The biggest reason we wanted to get rid of it is because the inside of the pockets was getting wore out enough that our spring clip teeth wouldn't stay into them anymore. So he'll have to run the part or the teeth with the C-clips on the back of them. They're a little bit more of a pain to change, but for what he's doing, he doesn't do near as many feet of trenching as we do, so you won't have to do it very often. If you get into mean enough rocks, it's possible to tear up about anything. Rip the tooth off the 3/4 plate there. It's also possible to shear the bolts out of the chain, lose cutters that way. This is what the completed chain setup looks like. We're cutting about 7 inches wide, maybe 7 1/4, and that gives you a tooth about every 1 1/4 all the way across it. You've got 6 different teeth here, 2 on the outside, on every other station, and then alternating left and right with 2 on every other station. Now that we've got the chain set up ready to go, it's time to get to work on the actual trencher. We're going to have one wear plate to replace, a couple other wear plates that need welded up, made thick enough to run for a while longer again. Then we've got 2 bearings to work on and a hydraulic valve that's dripping a little bit. We also need a new drive sprocket and a couple other little projects to work on. So start here at the back. This wear plate here is getting just about wore out, but we should be able to build it up. It's really not all that far. It's just right on the corner here that it's got quite a bit of wear. You get down the boom just a little bit, and it's thick enough to run for quite a while yet. So. Up here we've got the drive sprocket that turns the digger chain. You can see how it's getting cupped back quite a ways. And around here on the bottom, this auger sprocket here, we're probably going to go ahead and leave that one on. It's getting a little bit of wear, but it doesn't do a whole lot. It's not pulling any load other than just turning the auger. So we do have a problem with it though, because if you can see here, the bearings on it are loose. So we need to pull it apart and get to those bearings to get them to tighten up or get replaced. This was the first pass on welding up the wear plate on the bottom of the boom. It's a little tricky to get it to weld upside down, but it doesn't have to be perfect. That's 2.5 passes. That'll give us enough extra wear there to finish wearing out the rest of the plate. We're going to build up this wear plate the same way. It's a lot easier to run with when you're welding on top of it instead of on the bottom side though. And this top plate here is down far enough that it's beyond repair at this stage. We'll go ahead and torch the welds off, put new iron onto it, weld it back in place. Here's the drive sprocket that we took off. Set it on top of the new sprocket there just so you could see how much wear was coming off of it. The side that wasn't getting pulled against doesn't have hardly any wear on it at all, but the inside corner and the part that you were working on has taken quite a bit. Here we've got our top wear plate welded back on. We actually just built this one out of mild steel. You can buy them, of course, through the factory. That they're probably a T1 steel or something like that, but for us it's easiest just to run to the local welding shop and get the strap, put it in place. The top bar especially lasts a long time. It doesn't run with hardly any weight on it when you're trenching, so it's not very often you got to replace them. This nose roller out here, the bearings were getting a little bit loose in them too. There's shims that you could take out and tighten them up, but no more than the bearings cost. They're under $200 for the set of them, so it's really not worth it. If you run the bearings and ruin the inside shaft on that or the main part of the wheel there, you're looking at about $2,000. So it's a lot easier just to go ahead and put new bearings in it while you got it apart. That was the old cup and cone that comes out of that nose roller. I think they're actually a truck axle bearing. They're available at the local Napa store, so that's kind of handy. Back to this drive sprocket again. It is possible to turn them around and run them on the other side. Like I was showing you earlier, the back side of that tooth doesn't have much wear on it right there. Most of your wear is just on the other side. We had another trencher that we wanted to put it onto, so we went ahead and put a new one onto this one. Of course, guys that sell you the parts say that you can't do that, you'll wear out the chain too fast. The rollers on the chains aren't the first thing that wears out anyway, it's usually the side plates for what we're doing. Alright, now we get onto this auger bearing that was loose. We tried to adjust it and couldn't get it to adjust, so we ended up just cutting it off of there with a grinder and cut-off wheel. That's the easiest way that we found to take them off, is just to cut that housing in two. Sometimes you got to relearn something that you used to know how to do. We weren't able to get this bearing to adjust, but if we'd have known everything that was stopping it from adjusting, we probably would have been able to. That's the adjustment nut that goes on the outside edge of that bearing there. This is of course the one that was on the other side, and it's a little bit loose too. And then these four little set screws, see the two with the little ribs on them, the shoulders, they go down into the pre-drilled holes in that adjustment nut. Now whether there was always four or whether they used to build these things with just two set screws in them, I can't tell you. But we took out the outside two set screws that you can see and tried to adjust it and couldn't get anywhere. That nut screws into this part of the housing there, and you can see how we still had the inside set screw stopping it from turning. It's no wonder we weren't making any progress. So just to go over this one more time so you don't make the same mistake that we did, you've got the outer set screw, and down inside of the same hole, doubled up in there, is the inner set screw. And that's the one that actually stops it from turning. The outer one, I guess, is just there for a lock nut or to keep the threads clean or something. I don't know. After we got all four of the set screws pulled out, then we were able to take a hammer and punch, adjust that lock nut up a little tighter. You can see how hard we tried on it before we got that figured out though. The way that's mounted back here on the back of the machine, we wouldn't have had to even pull it off to get that done if we'd have known what we were doing. So live and learn. If you wanted to drill that adjustment nut out to get your set screw in like the factory had it, it's not that hard to figure out what size of a drill bit to use. In this case it's 5/32. For what we're doing, it wasn't a big deal anyway. We'll just set the set screw back in on the threads, not worry about drilling it. Here we've got it all put back together, chain put on, tension adjusted, adjusted the crummer to where it's the right distance from the end of the chain, got all the teeth put into it. This end of it's ready to go trench. We had a couple other projects to work on while we had it in the shop here. We've got one hydraulic valve that's dripping, so we needed to put some O-rings into that. It's up in that side of the boom on the backhoe, and then this door over here was about to melt off of it. Vermeer started making some plastic doors in here, and the exhaust sits right inside of it, the muffler does. And when you're running them when it's hot out, they get hot and warp up. Just basically wasn't their best idea ever. So we built a little bit of a metal frame there just to keep everything straight. Hopefully make it functionable for quite a while again. We looked at replacing these doors as something like $800. So hey, I can stand to look at a few rivets. Then finally we got to our hydraulic hose or valve that was leaking a little bit. It just had the quad rings around the spool leaking. The one on top, there's one on top and one on bottom. They fit into the little groove that you can see in the end of it there. Nothing too major, just took a little bit of work to get it drug out of there and get it where you could work on it. It was tucked in behind all the hoses on the backhoe, so you couldn't replace it where it sat. We get that put back in, and hopefully everything's good to go for a long time. Everything on here is just general maintenance, stuff that goes on when you got a trencher digging holes in the ground. Takes a little bit of time, but it's got to be done. Thanks for watching.